I want to talk about overfitting, underfitting, and generalization in this video. Let's do a quick recap of how model training works. When we do model training, we'll have data and then we'll have a model architecture. We will feed in this data to the model architecture, and the model architecture will figure out the pattern within this data. It will kind of learn the pattern within this data. And if it is a supervised learning, we may have a feedback loop like this, where the model's outcome will be passed in back to the model so it can learn from its mistakes. So this is how a normal training process works. And once the model is trained, we'll have model architecture, then the weights. Weights are basically the learning that has happened during the training. So we'll have data, and that data will have some pattern, and that pattern will be encoded in these weights. So this is what a training process creates. So the combination of model architecture and weights will give us the trained model. We'll have a trained model, and that is basically combination of model architecture and weights. Now, once we have the trained model, we'll be able to use the trained model for prediction or inference on unseen data. So this is very important. During the training process, the data we use is called training data, and once the model is trained, we'll use that model to predict or inference on unseen data. Okay. Now, after training, there is no such thing as perfect model. The model will never be 100% correct, because the models are probabilistic model, and we will never be able to create 100% perfect model. So when we use model on unseen data, one of these two things will happen. We might have correctly predicted result, or we will have incorrectly predicted result. One of these two will happen. Now, the success rate will always be less than 100%. So we can't ever create a model which has 100% success rate, because the models are inherently probability based, and because of that we will never be able to reach 100% accuracy. So the error rate will always be 100 minus success. When model success rate is really high on training data, and the model success rate is also high on unseen data, then that particular model is generalized well. We can say that that model has generalized well because it has high success rate on training data, which is the data that we used for the model training, and it has high success rate on unseen data as well, which means it has essentially learned the pattern in the training data, so it is able to perform well on the unseen data as well. So we call this as a model generalization. Okay, so we have created a generic model which performs well on training data as well as on unseen data. So like I said previously, once the pattern within the data is learned properly, once the training process has encoded that pattern inside the model, it will be able to perform very well on unseen data as well. Now let's understand what is overfitting and underfitting. So overfitting and underfitting are basically problems that prevent model from generalization. Okay, we know what is generalization means, and there are two problems that will prevent a model from reaching a generalized state. Let's imagine that we are working on a classification problem. We are working on a binary classification problem, and we have two classes. One is this pink circle and the other one is this yellow square. Okay, so the classification is a binary classification, and let's also assume that it has two input features. And if we plot them on a XY coordinate system like this, this is how it looks like. So we have a lot of pink circles in the top here, and we also have yellow squares at the bottom here. So this is how the data looks when we plot them on an XY coordinate. Now, if the trained model splits the data like this, so this line is called decision boundary. If the model is trying to split the data like this, then this is an example for overfitting, because this has learned the data so well. It hasn't learned the pattern within the data, it just learned that particular data so well. If you see here, this is just an outlier. So this is an outlier which lives on the other side of the classification. And similarly, these two are again outliers which lives on the other side of the classification. So the model has kind of memorized this data rather than learning the pattern within the data. So if we have a pink circle here, for example, then that pink circle will be classified as yellow square, but it should be classified as pink circle. So this is an example for overfitting. And if we take the same example, and if we have decision boundary like this, then this is an example for underfitting, because in this example, the model hasn't learned anything and the decision boundary is completely arbitrary here. It doesn't do any classification at all properly. So this is an example for underfitting. Now, a generalized model will look like this. If you see this example, there are some outliers. We have this yellow square above this decision boundary, and also we have these two pink circles below this decision boundary, but that's okay because these are outliers, and like we have seen previously, the model will never be 100% perfect. But if we have some data point here, for example, we know that that particular data point will be correctly identified as pink circle. So that is what we want. We don't want 100% accurate model. We want a model that learns the general pattern within the data, so it will be able to perform better on unseen data. So like I said previously, this is an example for generalized model, and this is a good model. Okay, so this is all I wanted to talk about in this video. I hope this is useful. Thank you.